Hello, welcome to the latest B live stream. This week we're going to be doing something that's quite interesting for those that are interested in working with B in the future. We're going to be overhauling the plugin system, or starting to overhaul it at least. So this is going to be a component that you'll be using a lot if you write plugins for B. So it's important that it's usable, it's got a nice interface and so on. So that's the plan today. So right now we have this plugin trait in B, okay, and it requires you to specify a few things. It requires you to specify the name of the plugin, a function that gets called on initiation, and another one that gets called on start. But this trait is rather old, and we've recently done a lot of work overhauling the structure of B so that we have a more clearly defined actor-like model. So I've gone through this previously in a previous live stream, but just for the advantage of people that aren't familiar with this, B uses an actor-like model where each actor in this case is called a worker, and workers implement this worker trait that allow them to specify which other workers they depend on, and allows them to perform certain actions on startup and also stop. They've also got the advantage that they have access to what are called node resources. So node resources are sort of singletons within the node that that allows certain parts of the node state to be stored. An example of this is the storage layer. The storage layer is stored as a resource, and it means that any of the workers can access the storage, and also the tangle is stored in a similar way. So this is quite useful. It means everything's accessible from everywhere else, and yet we also still have quite precise control over the lifetime of all of these things. So as you can see, each worker trait has got access to the node, and it can spawn tasks that should run until completion, or rather until the end of the worker. It can also register resources, so it can insert new resources and so on. It can access resources, and it's also got the ability to remove existing resources when it comes to the end of its lifetime. So we want plugins to largely operate in a similar way, but there are a few differences. So firstly, we don't want to excuse me, we don't want to be revealing all of the details of the actor architecture to all plugins that are used with B, because there are some internal details that are just not really useful for people that are writing a plugin, or they're not really specialized in a way that's ideal for plugins. And there are also several APIs that we might want plugins to have access to, which workers don't natively have access to. So this is a bit ad hoc, because I only thought about redesigning the plugin architecture a few hours ago, but the general gist of what I'm going to be doing today is I'm going to be turning this plugin trait into more of a wrapper over the worker trait that will provide more things and not provide all of the stuff that a plugin doesn't need to care about. And then maybe I'll write an example plugin just to demonstrate it to you. So the current plugin system is actually commented out right now, wherever it's gone. I've moved a lot of things around here, so here we go. Yeah, so we've actually commented out this. The reason for this is it wasn't really compatible with the new state of the node architecture. Another problem I have with it as well is that it requires plugins to be declared in B, which of course is not very adaptable. It means you have to edit B in order to add new plugins to it, which is not ideal. So the current system should be able to allow you to import B as a third-party crate, as a library crate, to write a plugin for it and add your plugin to it, and then run the node. Or alternatively, you can write your own plugin as an entirely separate crate, and an end user that wants to import multiple plugins can do so by including both the core B crates and also the plugin crates that they want, and then combining them together. So the way I'd like this to work, if we go to the main.rs file, this is the main file that runs B. So the way I'd like this to work is that you should be able to do something like this: node build, then afterwards with plugin, then you can specify your plugin, and then you can specify another plugin, for example. You can chain these operations together. And then you call .finish in order to finish creating the node, and then you'll call .run, or whatever the equivalent is. I think we call it run, and that will basically just run the node until it receives a shutdown signal. So this is the process I'm going to go through in order to try to refactor things and allow them to be structured in this way, which I think is quite utilitarian. It's fairly simple. It makes it really easy for people that don't necessarily know how plugins work or even want to know how they work to add them to the node. And hopefully it should provide plugin writers with all of the tools internally they need. So I mentioned previously that the node uses an actor model, so we'll be letting plugins plug into this actor model, so they'll be able to listen in on node events and things like that, and also register their own resources and define their own dependency plugins and things like that. Excuse me. So the first thing I'm going to do here is I'm going to define if I'm going to go into the plugin code. I'm going to comment this out for the moment because I don't think it's what we want to be working on right at the moment. Let's just remove the import. I think it was removed actually. Yeah, we import a plugin, but we don't actually use it. Okay, so oops. So I'm going to create a new trait, which is going to be the main plugin trait. I'm also going to create this worker. It's going to be parameterized over the plugin that it's controlling. So this worker is going to act sort of like a wrapper around the plugin, and it will allow the plugin to communicate with the rest of the B world in the same way that a worker would do. And then I'm going to import all of the relevant worker traits for it. So if we go back into worker.rs, we can see we've got to import, we've got to implement these things. So this is probably going to require adding more things to the plugin trait in order to make sure this is compatible, but I'm sure the compiler will give us errors that tell us exactly what we need to do. So we're also going to create a wrapper that wraps the error generated by the plugin and allows us to add extra information to it that might be useful when trying to report information about a bug. And it just means that the plugin writer needs to do the minimal work necessary in order to get this working. Going to allow defining plugin configuration. So you might want to, as in the previous example, I've got it right again, you might want to do something like .with plugin CFG and provide a bit of configuration to this plugin. So for example, you might want to parameterize exactly how it works, or allow it to talk to another part of your code base that's making use of B. Excuse me. Right. So this plugin's got no dependencies at the moment. We may add dependencies later. Just thinking about to what extent that would be a good idea. So we might want some sort of plugin manager type, or plugin manager worker later in order to set up an environment for them. But for now, I'm going to assume no dependencies. Right. So when we start the worker, the plugin worker, we're going to want to create a new instance of the plugin. So So we're going to need to define a start method that allows a plugin to specify behavior it wants to perform on the start. I'm going to make this one asynchronous because it's pretty useful to allow plugins to asynchronously depend on some behavior, for example I/O, and if they don't want to use async APIs, that's fine, they can just block the thread instead. That's probably okay in this context because this is going to be called from the main thread. Notice how the API of the plugin trait is starting to mirror the API of the worker trait. And in the future, we're going to begin to deviate from this and allow the plugin to specify more specific behaviors. Stop method, so that's going to allow the we'll make it consume self. So this is going to allow the plugin to stop itself and shut down and call any destructors it needs to call or perform behavior as the node stops running. Okay, so this should be broadly sufficient to begin to define a plugin. So first of all, I'm just going to check to make sure it builds, and I'm sure it won't do. I'm sure we'll get a plethora of errors, things I've forgotten. Okay, only a few more. Okay, so what we're probably going to do is convert this old plugin at some point, but for now I'm just going to comment it out. Maybe I'll do that towards the end of the live stream. Okay, just make sure there's nothing else. Okay, right. So that's fine, we can just import that. Okay, so we just need a send bound on plugin, which allows it to be sent between threads. I don't think we're going to need a sync bound. Oh, apparently we do need a sync bound, okay. Yeah, that should be fine. Yeah, I don't think that in itself is a problem. Okay, and another thing as well, because the worker trait requires the worker to have a static lifetime, which in turn will therefore imply that the plugin itself should have a static lifetime, so we need to specify that. And now we've hopefully made the compiler happy, or not. Okay, that's fairly simple. still one more, right? Okay, that's because the derive bounds are automatically wrong. That's just a somewhat annoying internal Rust problem. So you can see that the process of writing code in Rust is commonly to spend your time debugging problems and then going back to the compiler and debugging them again. That's the wrong one. Okay. We will get there eventually. Rust takes error handling extremely seriously. So seriously that it won't let you compile things. Okay, that's also fairly simple. And we've finally made the compiler happy. Right. Yeah, so I was considering requiring the error trait. However, I don't necessarily want to require that because it might be inconvenient to define error for something that doesn't already implement it or isn't really treated as an error. I guess it wouldn't be a huge problem to do that. Maybe I will do that actually. That's a fair point, Alex. Should just be possible to just plug that in. Yeah, but it's already got the same trait bounds internally. Right. So, despite the fact that this is so far starting to look almost exactly like the worker trait, I promise it will begin to split apart in time, but probably not in this live stream. But for now, I'm going to port the previous TPS plugin. So what did it require? Okay, it needed to register an event listener. So we're going to need to have access to that. I'm not sure whether we want to provide it access to the entire node though. For now, let's just provide it access to the event bus. Let me check the type of the event bus. Right. Oops, I didn't need to have that actually. Actually, maybe it is a good idea to have that. So the reason behind this is that the plugin will need to be able to register a listener that will listen into a certain event when we run the node. So in the case of the TPS plugin, it's just going to basically display a little bit of information about an event that occurs. This event being the tick event. So we start to define this. We don't need a name yet, although it might be worth defining one later. However, I currently think we can use the type name, so that would be fine. I'm just going to call it TPS instead of TPS plugin, just because it's a bit simpler and it's already clear that it's a plugin based on the fact that it's implementing the plugin trait. Right. sure. I'll probably rename the file then after the live stream, just because it's a bit inconvenient to do that now, but I'll take that into account. Okay, and we don't need a stop function. Yeah. So we can give the stop function a default. Okay, let's see whether the compiler likes our code. And there are some problems. Okay, we've got this tag which lets us define functions in traits as asynchronous. Oh, okay, apparently it's still called TPS on my end at least. I probably need to rebase in that case, but for now I'll just use that name. It requires an anonymous lifetime there. Shouldn't really require that, but maybe that's just a problem with async trait. Right. This might be an interesting one. No, it won't be actually. This will be quite easy to solve. Because we have an owning handle to the event bus, which means that we don't need to pass it by reference. Okay, and the compiler likes us again. So the next job is going to be to try integrating this into everything to try to get it to run. So we're going to go back to the main.rs file and try to clean this up a bit if possible. So create the node here. And then we wait for it to finish, or rather okay. this case, I think panicking is just going to be equivalent. Panicking at this location is basically the same as printing here, because it's just going to pass control flow back anyway out of the main function. Okay, I'm just, you can't see it on this screen, I'll move it over, but I'm just checking through another file to check to see whether this can be altered. So, where do we use this? Here we don't, we just create it once and then call this method on it. Okay. Right. I'm going to leave that as is for now. Now we've got the configuration for the node. It's time to actually create it. So I'm going to move this path up to here. So that it's a bit neater down here. And then of course we're going to add our with plugin function, which we've yet to create. This needs to go down here as well. Okay, so this cleans up this a bit, makes it a bit easier to look at, maybe a bit easier to chain more methods on and add more plugins later. So, time to compile it. This This might take some time, so I'm going to work on adding this method first because it's going to fail to compile anyway. Oh, yeah. Okay, so with plugin not existing is the only error. Okay, plugin's already imported here, that's good. So now we've created these methods that should allow us to create new plugins. So it's rather annoying. I think this works. Oh, whoops. That's interesting. That implies that it's still trying to read it as if it were. There we go. Right. I'm still not happy with this though. Yeah, so going to move this into a new directory so that we're separating out all of the plugin related definitions and the plugins themselves. Right. We'll get there at some point. Almost there. I think I just didn't save that file. Okay, right. So we're almost at a state where we can start to run our first plugin with the new plugin API, or what little exists of it already. Okay. The compiler likes us, so this should be the first moment where we have this plugin running. So it's designed to run every few seconds, or maybe it's every second, and just spit out a few interesting metrics about, remove this one now, about the node. Rustaceans unite indeed. Towards a better future with good programming languages and type-safe programs. Here we go. Right, so the node is now running, and we can see that it seems to be working. We have this being printed every second. So our event listener is successfully being hooked into the node, and is being called every second to produce all of this information. We don't actually have anything incoming at the moment because I don't think I have my node properly set up correctly on this branch. But that's tangential to the point at the moment. The point is it works, so that was a success. So in the future, if you were to run a node, you might do something a bit like this, where you'd create a node, you'd chain all the plugins that you need in, you'd provide configurations for them if you wanted to. And you'd hopefully have happy sailing. So we're at 8 minutes to, and I think we're pretty much done with this. Does anybody have any ideas for things to work on in the meantime, or things to show? Okay, well in the meantime I think I might refactor this a little bit. So I feel like the creation of this extra type here is a bit unconventional. I'd like to clean up a bit. So one thing I'm going to do is I'm going to go to the code for it, and instead of implementing this on CLI args, I'm going to implement this on node config builder. Now I've got to import backend, of course, which is actually, where is backend? No, that's part of the storage, isn't it? So now we should be able to use it inline like so. One second. I'm going to call it something a bit better. Apply to config. There's probably a temporary name. Okay, ideally we'd make this inline as well, but I think this is fine as it is right now. Let's make sure that compiles. Okay, error because I've done something stupid. Wait, we already had backend imported. I enjoy calling things with. I feel like it feels very nice to have builder methods called with. Oh, had an error because I started recompiling prior to properly saving the file. Well, the fact that it's not produced an error so far is indicative that that this works and the compiler likes us. We can just do a quick check just to make sure that it's actually going to run, but as is usually the case in Rust, if your program compiles, it'll probably run as well. Okay, so I think that pretty much takes us to the hour. If there's any questions, feel free to ask them, B related or Rust related or etc. There we go. Node is up and running, so that seems to work. If we can get a help menu up from it. I don't know if it supports this. Yes, it does. Okay, so we can do something like trace to get all of the information. So trace gives us even all of the debugging data as well, which might be useful if you're trying to debug a node that's not working correctly. So you can confirm that works. Right, I think that pretty much concludes today's coding session. Have a good week, everybody. See you later.